So today we're going to dig into a concept that feels really important right now called agentic accountability. We need to move AI agents from unpredictable black boxes to collaborators we trust.
That's it. I mean, trying to define a system where everything an AI agent does is traceable, verifiable, and governed by rules no single party can override. So it's about building accountability out in the open.
The really big shift, the core insight, seems to be moving away from just capturing intent and instead moving toward verifying the action. Was that intent actually carried through faithfully? Is there cryptographic proof?
That shift is necessary. You have to do it because agents operate autonomously. They have this delegated authority. If you only log the first instruction, you have no visibility into the thousands of little decisions that happen after that. You can't tell if it improvised safely or if it just drifted completely off course.
If these agents need to show their work, what kind of evidence are we talking about? This is more than just a typical log file, isn't it?
Oh, it's more rigorous. At every key checkpoint, the system demands an explicit, cryptographically signed record. This record has to capture everything. Who authorized the agent, what data it used to justify its action, and then what was the outcome? Did that outcome meet the criteria we agreed on beforehand?
That requires an incredibly robust infrastructure to support it. Let's look at the three core components. The first is a shared state where everything is visible. What makes that different from the normal database?
What's interesting here is that the state itself is distributed. It uses things like CRDTs mirrored across peer-to-peer rooms. The whole point of that architecture is transparency and making it tamper-proof.
Nothing can be hidden.
Nothing is hidden, and this is the big insight. The steps in a workflow become contracts, not just suggestions. An agent can't move to the next step unless the current step has been cryptographically completed. It stops dangerous improvisation.
So we have this shared verifiable state. But how do you control who is allowed to change it? You don't want one agent holding all the keys.
The system tackles using something called UCANs, a user-controlled authorization network. This is a huge leap from simple role-based access.
How so?
Authority is incredibly specific, revocable, and it's tied to certain objects and conditions. Every action an agent takes can be traced back to an explicit, limited delegation. It turns the fuzzy problem of trust into legible responsibility.
Final safety check. Outcome verification. How does the system prove what the agent did worked in the real world?
The actions produce what are called verifiable claims, maybe a prediction or a final decision, but they aren't just self-reported by the agent. They get checked by independent external truth checkers, often called oracles. Once verified, the claim is anchored. A permanent fingerprint is recorded on a public ledger.
Because it's on-chain, it can't be rewritten or denied. It closes the loop.
It closes the loop, yes.
This architecture sounds complex, maybe expensive in computing and brain power. Why go through all the trouble to build this entire thing so transparently out in public?
That's a great question. Concerns about centralized power. If you build this accountability system behind closed doors, you risk recreating invisible decision-making. Having it in the open acts as an early warning system. Trust isn't formed by what you're told to believe. It's formed by what you can inspect for yourself.
What does this mean for the future of intelligent cooperation?
Agentic accountability is the foundation for voluntary, scalable cooperation with AIs. The goal is to make autonomy dependable. It turns the agent from a scary black box into a collaborator that has a documented, auditable trail for every single thing it does.
If agents can justify actions, verify outcomes, and expose their reasoning, how will that change our human systems?